Hello, everyone out there. Welcome back again to our channel, Tutoring Made Easy. And the goal of this channel is that we are embarking on this math journey, and the goal of that journey is to make math easy and enjoyable. We want to eliminate any form of fear that people come in contact with mathematics. Um, if this is your first time of come in contact with our channel, we will need your help. We will need your favor to help us grow this channel by liking this video, subscribing to our channel, so that we can grow this channel together. It's a family. It's a family. Please help us. If you've also been watching our videos, but maybe you haven't had the time to subscribe, please subscribe to our channel. If you're already a subscriber, we want to use this opportunity to say a big thank you to you for already supporting us and growing this channel together with us. If you also have specific math topics that you want us to do a video on for you, please do not hesitate. Do not hesitate to drop those topics in the comment section below, and we'll be more than willing and glad to help do videos on that for you as well. Today, we're going to move on to another topic, and the topic for today is change of subject. Change of subject. Someone will say, "What is that? What does it mean?" Change of subject simply means that you have a formula. Maybe let's say you have x is equal to a plus b, and we want a to stand alone. We want a to stand alone. What are we going to do to make a stand alone? Sometimes they can also ask to find b, make b the subject, or to find b. How do we make that b stand alone? And that's what we are going to be getting into. Like, for example, currently we have x standing alone, right? We have x here. It is standing alone. That means that x has been found to be the subject, or has been solved for. Now, if you have, let's say, x equal to a plus b, and we are being told to make a stand alone, we need to let this b go away. How do we do that? The x will be here, and then this b is going to move to join the x, because we want a to stand alone. And whenever b is moving, because b is going to cross this equal to sign, this positive sign needs to change to negative b, and then we're going to have it equals to a. Therefore, our a is equal to x minus b. Is the whole of that. So now you can see that we've made it is possible. We've been able to make this a stand alone. The a stands alone. The a stands alone. So that's what we're going to be doing today. We're going to be making variables the subject, or making variables stand alone. We're going to make them stand alone. So we're going to start with the first one. Imagine we are being presented with this problem. Let's say we have v. V is equal to u plus at. Those of you who are doing physics, I know this will be a very familiar formula. Is a velocity formula. It's a velocity formula. But we're not doing physics today. We're not doing physics today. We are being asked. We are being asked to make a the subject. We're going to make a the subject. We're going to make a stand alone. To make a stand alone, make a stand alone. How do we do that? How do we do that? I know you're brilliant. I know you guys are having some ideas already. Certain things are going through your mind, certain ideas already. Now, we want this a to stand alone. So to do that, we need to let this u go away. We're going to have v is equal to u plus at, right? Yes, v is equal to u plus at. V equals u plus at. So we need this u to move here. We need this u to move there. And if it's moving there, we're going to have v. Sorry. Let me take my time. So it's this way, okay? We need this u to move here. We're making a the subject. It needs to come here. And when it's doing that, we're going to have v is equal to minus u. Why? The sign changes. The u is no longer positive. It is negative because it just crossed the equal to sign. So we have v minus u being equal to at over here. Now, we are seeing that a is attached to the t. What can we do to at so that a can be able to stand alone? I think the best thing to do is to divide both sides by t. So if we divide here by t and we divide here by t, why do we do that? Whatever we do to the left hand side, we have to do the same thing to the right hand side. Whatever we do to the right hand side, we have to do the same to the left hand side. Why? It's because an equation. We have an equal to sign. They are all the same. We're trying to say that this left hand side is equal to what? The right hand side. So whatever we do to this side, we need to do the same here. Maybe they are twins. maybe they are twins. That's why we need to be not. We don't need to discriminate. We don't have to discriminate. So anyway, we divide both sides by t, and in doing that, we have v minus u over t equals at divided by t, and this t cancels out, and we are left with v minus u over t is equal to a. Now we know that because of that, we know that our a is now equal to v minus u divided by t. If you don't find that in your answer, remember this is the same as v over t minus u over t. If you have a plus b over 2, is the same as a over 2 plus b over 2. So don't forget that principle. It's very, very, very important. It's very, very, very important. So that is where we end for this particular problem. The second one we are going to be looking at, is pretty much P. There's another question. And in that question, it's saying that we have, let's say, P is equal to M divided by M plus N. And then we are being asked to we should make M stand alone. We should make M stand alone. Let's make M stand alone. Now, what are we going to do? Now, look at the first key here. The first key here is this equal to sign. So we can rewrite this as P over 1 is equal to M over M plus N. We've rewritten this as this. Now, remember, we studied in fractions or in indices. You have A over B equals to C over D. Because of this equal to sign, we do what we cross multiply. Please do not forget that. This A can multiply that. It's going to be A times D is equal to B times C. So you have AD is equal to BC. So we're going to apply that principle right here. So we are going to have P over 1 is equal to M divided by M plus N. But this time we're going to multiply this by that. And to do that, we're going to have, it's going to be P multiplying M plus N, right? It's equal to, this one is also multiplying that. That one is multiplying M. That's it. We do not have to do anything here, multiply anything there, because we have equal to sign. We don't have any form of maybe addition sign or subtraction sign in the middle. What we have in the middle is just equal to sign. So we just cross this one, we multiply this and multiply that, and then we are done. Now, we're not really done yet. It means that this P will multiply this M, and we're going to get PM, and then this P2 will multiply this plus N, and we're going to get plus Pn, which is equal to this times this. 1 times M will give us M. Now remember, we are being asked to make M stand alone. Now we are getting there. It's getting clearer. There's something with M here, and M is also there. So I think they should come together. Remember algebraic expression, rearranging like terms together. So in doing so, in achieving that, we're going to have PM stand here, and then we have in Pn is equal to M. What do? We need to make this M come over here. And when we do that, we're going to get PM plus Pn minus M is equal to 0. Can you see that? I hope you can see that. And then we can continue somewhere here. We are going to get PM plus Pn minus M is equal to 0. And then once we've been able to do that, we can rearrange. We have PM minus M plus Pn is equal to 0, right? Why did we bring this one here? Because this one also has M there. But we don't need this. This needs to move away. It needs to go. We need to move this away because it doesn't have M in there. I hope you agree. I know you're agreeing with me. And to do that, we're going to move that to the other side. So we're going to have this go here. And when it's going there, this plus sign needs to change. So it's going to be PM minus M equals 0 minus Pn. Pn, N for Nancy. And then once we do that, we can now be able to factorize because m is common here. So we bring m, we factorize m out because it is the common thing there. So we bring m out, and then we are going to have p minus 1. This once we bring m out, it's left with only 1 there. It's equal to minus pn. 0 minus pn is minus pn. Minus pn. Now, we don't want m multiplying p minus 1. We need only m. We want m to stand alone. And to do that, we will divide here by p minus 1. And divide here also by p minus 1, like this. So this cancels out. And then eventually, we are having m. We are having m to be equal to minus pn divided by p minus 1. Where p cannot be equal to what? 1. Because if p is equal to 1, m is going to be undefined. M is going to be undefined. I hope everything is getting clearer and becoming a bit easy. Let's try another one. I'm having more examples here, but let's try another one. Let's say you have S is equal to ut plus half of at squared. Those of you who are doing physics, some of these formulas will come easy to you. But we're not doing physics today. So we're doing math. So we're trying to make we're going to make a stand alone. We want a to stand alone. So the first thing we're going to do is to move, right? Is to move ut to another place. So s is ut plus half of at squared. We want a to stand alone, but you can see this is the foreigner, so we need to move it away. It needs to come over here. And in doing so, the sign of ut will change to minus ut. It changes to minus ut because it crossed the equal to sign. And we are going to have equal to this half at squared. Now you're having, we are having s minus ut, which is equal to half at squared. Now, this is don't be frightened. We can rewrite this. Don't be frightened. Don't be scared. We can rewrite this carefully as a fraction. This s minus ut, we can write it as a fraction. Remember, if you have 2 and I say, hey, I'd like you to write 2 as a fraction, it's simply 2 divided by 1. If you have 100 and I say write 100 as a fraction, it's simply 100 over 1. If you have 3 and I say write 3 as an exponent, in terms of an exponent, it's going to be 3 to the power of 1. If I say write 3 as a decimal, it's going to be 3.0. So it's the same thing. We can write s minus ut as a fraction as s minus ut over 1. I hope that clarifies why we are doing that. Okay, we want to do that because this side is already, because the right hand side is already in fraction form. So we want to make the left hand side also in fraction form. So we have s minus ut over 1 is equal to at squared divided by 2. Can you see that? So now we'll have the left hand side being a fraction and then the right hand side also being a fraction. And once we have equal to sign in the middle, don't forget this rule. A over b, a divided by b equals to c divided by d. The moment we have an equal to sign in the middle, we can cross multiply. Do not forget that. We can cross multiply. And in cross multiplying, we're going to have s minus ut over 1 equal to at squared over 2. This is going to multiply that, and that is going to multiply that. So the first thing we're going to do is we're going to have s minus ut multiply 2, right? And it's equal to 1 multiplied by at squared. Now, this is going to multiply this. We get 2s. And this same 2 multiplying this, we're going to get minus 2ut is equal to at squared. But we need a. We need a. We need a. And as we need a, we are going to divide that a, that at squared that we have, which is 2s minus 2ut. We are going to divide that by t squared. We need to divide it by t squared and divide it by t squared. And we are going to get a to be equal to, this is going to cancel that. So a is going to be equal to 2s minus 2ut all over t squared. All over t squared. So people can write this as Some can write this as 2s over t squared minus 2ut over t squared. All right? And then we know that this can cancel one of it, and we are going to have 2s over t squared minus 2u over t. And then that's our a right there. I hope this is helping. I want us to do one more, and then maybe we bring this, make change of subject. We bring it to maybe a close. Um, let's look at this one right here. Let's say we have 1 over big R being equal to 1 over small r1 added to 1 over another small r2. And we are being asked to make r2 stand alone. Make r2 stand alone. What do we do? What do we do? Now, can you see this is a fraction? So let's deal with that one first. We can add the fraction. So we're going to get 1 over r is going to be equal to 1 over r1 plus 1 over r2. We're going to multiply this by this, that by that, and this by this. So we're going to get, eventually we are going to get, we said this by this is going to give us 1 times r2. Yes? Plus this times this is going to be 1 times r1. Divided by this times this is going to be r1 multiplied by r2. We have in here to be 1 divided by big R. 1 divided by big R. But we are not done yet. We're not done here. We need to simplify the R, the right hand side. And to do that, this gives us R2, and that gives us plus R1 divided by R1, divided by R1, R2. Okay? Now, can you see that we had A over B equals to C over D? Because this equal to sign is standing between two fractions, we just multiply this by that and multiply this by that, and we are done. We don't need to do anything here. So to do that, I'm just changing colors. To do that, we're going to multiply this by that. So we're going to get 1 multiplied by R1, R2, like this, which is equal to this big R is going to multiply R2 plus R1, like this. And then I'll change color again. This is basically going to be 1 times the whole of this. It gives you R1, R2 is equal to this times this, gives you big R, small r2, another big R plus big R and small r1. But remember, we want to make r2 stand alone. There's another r2 here, so they can join together. They can be friends. Sorry. They can be friends. Yeah, they can be friends. This can be friends. So we're going to continue here, and by saying that the R1, R2 can have this joined here, and that will become minus big R, small r2, which is equal to the big R, small r1. Now, how do we make R2 stand alone? We can see that R2 is here and it's also here. So we can factor that one out. Have R2 out, and then we have R1 inside minus big R, which is equal to big R and R small 1 right there. All right. Now we are getting closer to ending this topic, and I hope you're enjoying it so far. If it's becoming challenging or it's not too clear and it's clumsy or blurry, please pause the video, go back a little bit, take a break, get some water, freshen up. Maybe you can come back again, and it will come clearer to you. It will become clear to you. So now we have R2 multiplying R1 minus big R being equal to the right hand side, which is big R and small r1. We can now divide both sides by the small r1 minus the big R. Small r1 minus the big R. We can cancel that out, and then we have R2 to be equal to big R, small r1, all over small r1 minus big R. So we've been able to make R2 stand alone. We've been able to make R2 stand alone. And I hope you enjoyed the topic for today. Change of subject or making variables stand alone. If at this point you haven't yet subscribed to our channel, we want to grow our channel. We want to grow our channel so that it can be able to serve the entire world of people who are scared of mathematics. We want to make math easy and enjoyable. So please feel free to share this video, like this video, and subscribe, and then share it to as many people as possible so that they can begin to enjoy math. If you have specific topics that you want us to treat, feel free to drop it in the comment section below, and we'll be more than willing to do videos on that for you as well. If you are a current subscriber, I want to thank you for subscribing and growing our channel with us together. I want us to leave this topic here. I'll come to you another time. Take care and bye.